Okay, so as you could probably guess, today we are talking about vectors. So some of you who have taken physics may have a little bit of a knowledge of vectors, but we're going to look at them probably in a little bit different approach than what you did in physics. So the first thing we need to do is define what a vector is. So a vector has what we call an initial point, and it has what we call a terminal point. Okay, and then we indicate the direction of the vector by drawing an arrow from the initial point to the terminal point. Now, don't get this confused with a ray. It doesn't go on forever. The vector has a definite length, which is called magnitude, and it has a definite direction, which is indicated by the arrow. Okay, so a couple of things. Do not mix up with a ray. Array in geometry goes on forever and ever. Okay, vectors, as you saw in the video, have magnitude, which is basically the length of the vector, and they have direction. Okay, and direction is usually given by an angle, or it's shown in the direction with an arrow. There is something called the zero vector. The zero vector has a magnitude of 0. And then there's something called the unit vector, which has a magnitude of 1. Okay. Two vectors are congruent if they have the same direction and magnitude. Okay, and then we can do lots of things with vectors. We can add vectors, we can subtract vectors, we can do something called a scalar multiple of a vector, and we can do those both algebraically and geometrically, drawing a picture. Okay, so we're going to add a couple of vectors here geometrically. So if you look here, we have a couple of vectors. I call them vector W, vector V, and vector U. Okay, notice they all go in different directions and they have different lengths. So we want to draw the vector that we get when we add vector W to vector U. So what we do is we recreate vector W. I kind of like to use slope. So if I go here, vector W starts at its initial point here, and then this is its terminal point, and I look at the rise and the run. So it rises 1, 2, 3, 4, 5, 6, and runs 1, 2, 3. So I'm going to draw vector W, and it doesn't matter where you start, it's the same vector. So I'm going to rise 6, 1, 2, 3, 4, 5, 6, run 1, 2, 3, and I've recreated vector W. Those are the same vectors. Even though they're in a different position than each other, they have the same direction and they have the same length. Now we're going to use something called the tip to tail method. So this is the tail of vector W. On the tail of vector W, I'm going to add vector U. So here's vector U. So vector U goes in a horizontal direction, and it's 1, 2, 3, 4, 5, 6, 7 units long. So 1, 2, 3, 4, 5, 6, 7 units long. There's vector U. Now, what is the result of adding those two vectors? The result of adding those two vectors is when you connect the initial point of vector W to the terminal point of vector U. So right here, this is a new vector. When you add two vectors, you get a new vector. This is vector W plus U, and it's called the resultant vector. So when you add two vectors, you get yet a new vector, and that new vector is called the resultant vector. So now we're going to look at subtracting two vectors and taking the scalar multiple of two vectors. So what this means is I need to take vector u and I need to multiply it by 2, which means I take twice its length. And then I'm going to subtract vector v, 3v, so 3 times vector v. So let's start with this. Let's start with 2u. If you remember correctly, u was 7 units horizontally. So 1, 2, 3, 4, 5, 6, 7. Here's vector u with 7 units horizontally. Now I need to double that. So I'm going to go another 7 units. So 1, 2, 3, 4, 5, 6, 7. So this is another u. So that entire vector from this initial point to this terminal point is 2u. Now I have to subtract 3v. Okay, ooh, I'm probably going to go off my paper here, but we'll see. I should have started a little lower. In fact, I'm going to do that. I'm going to move mine, and I'll show you why that is in a second. There's 2u. I'm going to recreate it a little lower, because now what we have to do is we have to subtract 3v. So let me go back to my other paper. Here's what vector v looked like. The opposite of vector v, so if this is vector v, being this the initial point and this the terminal point, the opposite of v goes in the exact opposite direction. So in other words, this goes over 1, 2, 1, 2, 3, and down 1, 2, 3. So negative v would go 1, 2, 3, 1, 2, 3. This would be negative vector v. It would be in the complete opposite 180-degree direction from vector v. So if this is v with its initial point here and its terminal point here, negative v would have the same initial point, but its terminal point would be in 180 degrees the opposite direction. So what I need to do when I want to subtract 3v, what I really am doing is adding negative 3v. So from here, I'm going to add 3 of the negative. Now remember, vector v went down this way. So negative v is going to go that way, and I need to do 3 of them. So up 1, 2, 3, 1, 2, 3. There's 1 negative v, and then I need to do it. I'm still going to run out of room. 1, 2, 3, 1, 2, 3. There's 2 of them. And I have to do 3 of them. So 1, 2, 3, 1, 2, 3. So there's a negative 1. So there's 2u going in the horizontal direction to the right. And then I add 3 negative v's. Now where's my resultant? My resultant is if I went straight from the initial point of the first vector to the terminal point of that vector. So this vector is 2u minus 3v, and this vector is called my resultant vector. Okay? All right, so let's take a look at finding the position vector. Now remember, A vector can have a different position, but as long as it has the same direction and same magnitude, it's the same vector. So what this is saying is if I start at the point 3, 2, so let's say P is my initial point and Q is my terminal point, how do we write this vector? And there's two ways to write vectors. I'm going to show you that. So I'm going to do a little coordinate plane here. And I'm going to go to the point 3, 2. Okay, so there's point P. And point Q is 5, 6. So 3, 4, 5, 1, 2, 3, 4. Okay, so there's point Q. So that's the vector. Okay, but how do we write that in its vector components? Vectors are written two ways. They're written in sort of like coordinate points, but like these pointy brackets, or they're written in the form AI, I representing your horizontal, and J, BJ, B representing your vertical distance. So what is the horizontal distance here? It's 2 this way and 4 this way. So this is the vector 2, 4. And basically I got the horizontal component by subtracting the two x's, and you always do the terminal point minus the initial point. So it's 5 minus 3, which gave me the 2, and then 6 minus 2, which gave me the 4 for the vertical distance. So this vector is 2 this way and 4 this way. The horizontal component is positive 2 because I went in the positive 2 direction, and the vertical component is 4 because I went up 4 units. If my vector went the other way, my vertical component would be negative. Okay, this can also be written in the form 2i plus 4j. These are both different ways to write vectors. Now, let me show you 2, 4, the vector 2, 4. Let me graph that. It means I go 2 units, so if I start at the origin, 2 units and then 4 units. 1, 2, 3. Okay, this pink vector here and this purple vector here are the same vector. They have the same length, they have the same direction. Okay, they're just in a different position on the coordinate plane, but that doesn't make them different vectors because they have a different position. They are the same vector. And the position, which we're going to learn a little bit later, is indicated by this angle that it makes with the positive x-axis. So if I had put another little, say, coordinate plane right here, this one would make that same angle with the positive x-axis. Okay, so how do we find the length of the vector? That's something called the magnitude. The magnitude and the length are the same thing. Okay, and it's indicated by 2 double bars. So if this is vector v, this symbol here with the 2 bars around v means find the magnitude of vector v. So let's go ahead and graph this vector. You're going to see it's just Pythagorean theorem. Okay, so what does this vector 2i minus 3j means? It means I move a positive 2 in the horizontal direction and negative 3 in the vertical direction. So if I start at the origin, I'd go 2 units this way, 1, 2, 3 units this way. There's the vector v. Positive 2 on the horizontal, negative 2 on the vertical. Okay, I want to know the length of that. Well, the magnitude is a simple formula. I'm going to write the formula down and you'll see where it comes from. it's a squared plus b, square root of a squared plus b squared. As you can see, that's just Pythagorean theorem, because this is 2 units, this is -3 units, and that becomes the hypotenuse of the right triangle. So what I would do is I would do v squared equals 2 squared plus -3 squared. V squared equals 4 plus 9. V squared equals 13. V equals the square root of 13. So we say the magnitude of vector v is the square root of 13. Okay? It's just Pythagorean theorem. And so you can use this formula of the square root of a squared plus b squared, where a is your horizontal component and b is your vertical component, and it doesn't matter whether it's positive or negative because it's squared.